Hey kids, so today's session is about deriving the formula for resistivity. Resistivity of a conductor. Resistivity of conductor. Okay, so we know what is resistance, right? Okay, so resistance of a conductor we know. In our earlier video we have covered that. So resistance is directly proportional to length of the conductor, right? Okay, so if the length of the conductor is small, length is small, so resistance is less. Length is big, so the electrons have to pass all these obstacles, right? Okay, through a longer duration. So length is more, resistance is more. So length is directly proportional to the resistance. Okay, other way around, resistance is directly proportional to length. Also, resistance is inversely proportional to area of cross section. Suppose there's a conductor with a smaller area of cross section, okay, right? So its resistance will be more. If area of cross section less, resistance is more. If area of cross section is big, like this, okay, so electrons can easily flow. So area of cross section is big, so resistance offered by that conductor is low. So resistance is inversely proportional to area of cross section, right? So we can write like this, combining these two. Okay, resistance is directly proportional to length and inversely proportional to area of cross section. When we remove the proportionality, okay, we'll have a constant there, right? Okay, and this constant is nothing but resistivity of the conductor. So R is equal to rho L upon A. Okay, R equals to rho L upon A. Remember that resistivity is material specific. Okay, resistivity is material specific, but resistance is not material specific. Resistance depends upon the physical state of the conductor, right? Okay, length, area of cross section, temperature, right? Okay, but resistivity is material specific. Okay, it only depends upon the material. So if R equals to rho L upon A, so we can write like this: resistivity equals to R A upon L, right? This A goes that side, L down, so rho equals to R A upon L. Now if suppose we have to find out the SI unit of resistivity, okay, SI unit of resistivity. So if resistivity is equal to RA upon L, R is ohm, A is meter square, length we measure in meters, so this meter and meter gone. Okay, what remains is ohm meter. Okay, so in this way we can actually prove that SI unit of resistivity is ohm meter, right? Okay, so remember this, can be asked for 2 marks. Resistivity is material specific. Resistance depends upon the length, area, temperature, also material. Okay, and resistivity's unit, SI unit, is ohm meter. Okay, so keep practicing, do your best. Bye bye.